Students, earlier we have proved that sin square theta plus cos square theta is equal to 1. Now next identities is 1 plus tan square theta equals sec square theta. How can we prove? Just like previous one, we have to apply here again Pythagoras theorem, and the same equation number 1 is applied in finding out and setting up the relation. See, again the same triangle. This one is at 90 degree. Any triangle containing 90 degree is called right angle triangle. So this triangle is also right angle triangle. Like you may observe here, this one is 90 degree, this one is theta. For this triangle, this YZ is base of triangle, this XY is perpendicular, and XZ is again hypo. The same status will be there as of the previous one. On the basis of this, we have to establish the relation between tan and sec. What relation between tan and sec is there? How can we establish 1 plus tan square theta is equal to sec square theta? Because we require sometime in the form of tan, sometimes we require in the form of sec. So it is the requirement of mathematical calculation. So we have to simplify and establish how we can prove this 1 plus tan square theta equals sec square theta. So what to do? We have earlier established the relation, and we know for every right angle there is a Pythagoras theorem. Every time when you are solving right angle triangle, the theorem is more helpful than other theorems, and that is Pythagoras theorem. Pythagoras theorem is always followed by right angle triangle. So what is right angle triangle? Perpendicular square, xy is what? Perpendicular square plus base square equal to hypo square. So perpendicular means xy square, perpendicular square. Yz is base, so yz square means base square equal to xz whole square, and what is xz? That one is hypo. So this one is A, this one is B, and this one is C. So A square plus B square equal to C square. How can we determine C? C is the longest side, and that is hypo, because hypo is the longest side in right angle triangle. We have discussed it, or there so many times we have discussed it. So hypo is the longest. So this one is A, this one is B. It is not compulsory that this one is always A. It can be taken as B also. So this will be A. So either say A square plus B square or B square plus A square. It depends upon us to choose and select here. Now this one is A square plus B square equals C square as per Pythagoras theorem. So now this equation number 1 is divided by, firstly we have divided by xz whole square. Now we have to divide by yz whole square. Both of the sides will be divided by yz whole square. See what happens? Left side will be divided by yz whole square. Similarly, right hand side will also be divided by the same yz whole square. Now see, by dividing what is there? Xy whole square. So xy whole square is noted down, and it is divided by yz whole square. Again, second one is yz whole square. So I have noted down here yz whole square divided by, again this one also be divided by yz whole square equal, so mark of equal will be there. Now here xz whole square we have noted down, and this will also be divided by the same quantity. And what is same quantity? Yz whole square. See, yz whole square upon yz whole square means total equation is divided by yz whole square. Now see, again we have some exponents law, and we have to apply exponent law. If p to the power m upon q to the power m is given. So power m is common there. So this common power will be noted down once here. This, see, common power 2 is there and it is noted down in numerator as well as denominator. So we can reduce for our convenient. This power 2 will be noted down only once if single bracket is taken. Here 2 brackets are there, so 2 squares are required. If we are converting into single, so that will be xy upon yz, and this will be kept inside single bracket, and common power will be noted down only once. This is the law of exponent and we can apply here. Similar cases here, 2 brackets are there, common power, so single bracket will be there, these things will be noted down as it is, and single power of 2 will be there because common power is written only once. If different brackets are there, so they will be noted down differently, but here single bracket is there, so common power is written only once. Now equal mark. Again here same pattern is adopted. So what to do? Xz upon yz will be noted down and common power 2 is mentioned only once. You know the reason? I explained here. It is the law of exponent. So here we have to apply law of exponent. Now after see what happens. Xy, what is xy here? Xy is perpendicular. In the place of xy it is written p. P means perpendicular. Yz it is base. Base is represented here by letter b. So p upon b means perpendicular upon base. Power 2 is already there. Power 2 is noted down. Now see, if yz is divided by yz, same numerator and denominator, so that value becomes 1. And in the place of this, we can note down 1. Is it clear here? Now, in the place of equal mark, we have to note down equal mark. Now, xz, see the figure, xz is hypo. The xz is hypo, that is indicated by letter h. Again, yz is base, and base is represented by b. Now p upon b whole square plus 1 square equal to h upon b whole square. Try to follow. P upon b means perpendicular upon base. It is the ratio of perpendicular upon base. And you know what is called if perpendicular upon base is taken in the form of ratio. So that it becomes tan of theta. Tan of theta whole square is there, that's why it becomes tan square theta. Now square of 1 equal to 1. Again here it is the ratio of hypo to base, and a ratio of hypo to base is called sec of theta. So in the place of h upon b we have to note down sec theta. Square is already there, so we have to put here square. Now ultimately what is obtained here? Tan square theta plus 1 equal to sec square theta. Now we have established here tan square theta plus 1 equals sec square theta. It means what? In the place of sec square theta, we can note down tan square theta plus 1 or 1 plus tan square theta. Now this one is established here. Or in any place where 1 plus tan square theta is there, so that will be equal to sec square theta. So left side is equal to right side and the right side is equal to left hand side. In the place of left hand side, we can note down right side. In the place of right side, we can note down left side. It depends upon the need of the question. As we feel or experience or realize the need, in the place of sec square theta, we can note down tan square theta plus 1. If we feel that in the place of 1 plus tan square theta is replaced by sec square theta, so we can replace it. It depends upon the situation and circumstances of the question. So we have established here. Now you know commutative 1 can be shifted to first place and tan square theta can be shifted to second place. So this can be noted down 1 plus tan square theta equals sec square theta. Now a formula is established here, and this one was required here. This one is second identity. What is the first one? First one is sin square theta plus cos square theta equals 1, and this one is 1 plus tan square theta equals sec square theta. This one is second one. Now on the basis of second one, we can draw two more results. We can draw two more results on the basis of this second identity. How? By transposing. See, one will be noted down here. Now tan square theta will be shifted to right hand side. We are going to transpose. While transposing, operation will be changed. What mathematical operation is there? Just reverse operation is taken there. Now 1 is here, and sec square theta is just after equal mark. So sec square theta is as it is with the same symbol, but here plus tan square theta. When it is shifted to right hand side, it will become minus tan square theta. So it means 1 equals sec square theta minus tan square theta. Sometimes in the place of 1, we have to note down sec square theta minus tan square theta, or in the place of sec square theta minus tan square theta, we have to put directly equal to 1. So this is identity. This will be behaved also as identity. We can take it because this is derived from this second identity by transposing the sides. Now it is not compulsory that always we transpose tan square theta to that one. We can transpose this one. Sec square theta can be transposed here, and tan theta will be in the same place, and 1 can be also transposed there. So what happens? See, here tan theta will take its place, 1 will be transposed there. So tan square theta equals sec square theta will be noted down. Now plus 1 is going to right hand side, so that will become minus 1. Now on the basis of this single identity, we have derived two more results. So you may observe how useful this identity is. Every identity is deriving two results. First one also has derived two results, and this identity has also derived two results. So 3 results from there and 3 results from here. It becomes 6 results. So we can apply different results at different places and different requirements. So we have proved here second identity. Now it is to prove the third one, and third one is also equally important as first and second is there. So we have to discuss and prove that one also. Now observe only this much. Focus yourself. See this figure. Focus here. We have to show that 1 plus cot square theta equals cosec square theta. What to do? Again we have to take the same Pythagoras theorem. A square plus b square equals c square. A is the indication of base square, b is the indication of height square or perpendicular square, and c is the indication of hypo, because c is the longest side and hypo is the longest side of right angle triangle. See, so same Pythagoras theorem, yz whole square plus xy whole square of this side plus square of this side equal to square of this side, the square of this one plus square of this one equal to square of hypo. It is noted down here. It becomes yz whole square plus xy whole square equals xz whole square. And here you have to write the region yz written, and that will be the same region, that is Pythagoras theorem, as every right angle triangle is followed by Pythagoras theorem. So now this will be divided by here xy whole square. We have to divide this equation by xy whole square. Here it is remarkable. Sometimes xz is taken, sometimes yz is taken. This time we have to take xy. We have to divide the equation, same equation, by third quantity. Earlier we have divided by two quantity. First one was xz whole square, second one was yz whole square. This one is third stage, and this will be divided by xy whole square. So we have to select for particular place. Now dividing the equation by which one? Xy whole square. Dividing means left hand side will be divided as well as right hand side will also be divided with the same fixed quantity, and that is xy whole square. Now first we divide left hand side, yz whole square. So yz whole square is noted down and it is divided by xy whole square. Again second one is xy whole square. Xy whole square is noted down and it is also divided by xy whole square. See, third one is equal, to equal mark is noted down as equal mark. Then xz whole square, and this will also be divided by xy whole square. See, xy whole square, xy whole square, xy whole square. Both left hand side and right hand side are divided by xy whole square. Now see, here different powers are there, not different powers. 2 times brackets are used and common powers are there. Same thing is here. Common power and 2 brackets are there. Again here 2 brackets and common power. So again we have to apply the same law of exponent. What is law of exponent? If p to the power m upon q to the power m is given, so we can convert this one into single form p upon q whole to the power m. Means bracket will be common and power will also be common. So what will be there? Common bracket, and this will become xz upon yz xy, and whole power to the, this one is common power, 2 is here, so power 2 is common and bracket is also common. Here also we can apply common power 2 and common bracket, single bracket. Again here after equal 2 brackets are there, so single bracket or common bracket, and power will be common, that will be power 2, because here 2 and here 2, so 2 is common, so power, common power is always noted down once. So this one is yz upon xy whole square, xy upon xy whole square, xz upon xy whole square. Now at this space you have to reduce. Which quantity can be reduced here? Xy will cancel to xy because both the numerator and denominators are equal. If numerator and denominators are equal, so the value will be equal to 1 and 1 square equals 1. Now see, this one is reduced to 1. Now see, yz, see the figure yz, yz is base. In the place of yz we have noted down b for base. xy is perpendicular. In the place of xy I have noted down p. This one is reduced to 1 square. Again xz is hypo. In the place of xz we have noted down here h for hypo. Again xy is perpendicular. xy is perpendicular, so in the place of xy I have noted down here p. So this result is b upon p and power 2 is already there. This one 1 square equals h upon p whole square. As we know, the ratio of base to perpendicular is cot of theta, and square of cot of theta is cot square theta. Square of 1 is 1, equal mark is equal mark, and the ratio of hypo to perpendicular is what? Cosec of theta. Hypo to perpendicular, the ratio of hypo to perpendicular is cosec of theta. So h upon p, hypo upon perpendicular whole theta means cosec whole square theta, and that will become cosec square theta. Now again we have established cot square theta plus 1 equals cosec square theta. Now third identity is proved here. On the basis of this third one, we can derive two more results. And what are those? By transposing the quantity. Now transpose this one to that side. What is obtained there? Cot square theta, 1 is transposed there. So what will come? Cosec square theta. And plus 1 is transposed to right hand side, it will become minus 1. So cot square theta equals cosec square theta minus 1. It is not compulsory that always 1 can be transposed there. 1 will be in the same side. This cot square theta will be transposed to right hand side. Now 1 equals, this is going to be transposed there. Say cosec square theta minus cot square theta, and this one equal to 1. Meaning is that if it is cosec square theta, the per requirement in the place of cosec square theta, one can note down 1 plus cot square theta or cot square theta plus 1 as per requirement. In the place of cot square theta, we can note down cosec square theta minus 1, or in the place of cosec square theta minus 1, we can note down cot square theta. In the place of 1, we can we can write there cosec square theta minus cot square theta. If cot square theta, cosec square theta minus cot square theta is noted down, it is in this form, so directly we can note down that this result is equal to 1. And all these results are derived from the basic identity number third, that is 1 plus cot square theta is equal to cosec square theta. And all these identities are very helpful while solving or proving this type of theorem, this type of problems, this type of identities, and they are very useful while we are going to solve trigonometrical identities. That one is given, prove left hand side equal to right hand side. So these basic identities are applied there, and applying these basic identities, we can solve different problems from time to time as per the requirements. So in this way, we have studied today basic identities. And how many basic identities are there? There are 3. What are those 3? First one is sin square theta plus cos square theta equals 1. Second one is 1 plus tan square theta equals sec square theta. And third one is 1 plus cot square theta equals cosec square theta. Thus, we have studied basic identities. I think you understand. If any problem is there, you may ask, you may inquire it from time to time, but try to remove your confusion. If any kind of difficulty is there, you may mention it, so that that confusion may be removed from your mind. I hope you will appreciate, you will understand. Thank you very much.